TypeScript is useful. So, okay, so I used to hate TypeScript. I used to be a TypeScript hater, and I admit it because I'm a JavaScript guy, and why do I need types? And then I went to work at a large organization that had many developers all developing in the same code base. TypeScript became a little more useful in that scenario. So I'm not completely anti-TypeScript now. If I'm writing something myself, I don't use it, but if I'm writing something with a group of people, it's definitely the right tool for the job. Okay, in the room, I've got 1 minute. In the room, who in the room would classify yourself as a .NET developer? Java developers? Okay. Ruby developers-ish? Python? PHP? Okay, excellent. Hi. I haven't hugged you yet. After, okay. Everybody meet Lemon. Lemon is the only person who consistently kills me at PubConf, and we'll see if that continues tonight. Now I'm distracted. I'm sorry. Okay. So who in the room, did I miss any? Who in the room would classify themselves as a JavaScript developer? Right, and what's interesting is a lot of you raised your hands for more than one of those things, right? So we're no longer just, I'm a backend developer, or I'm a, if you're a .NET developer, you kind of need to know some JavaScript. And so what this talk is going to be is kind of a discussion about functional JavaScript. Who in the room classifies themselves as a functional developer? Okay, 2. I'm going to warn you now, you may become angry over the course of this talk and throw things at me, and it's fine, kinda. Like nothing hard or wet. Other than that, I don't care. Because I'm not a functional developer, I'm a JavaScript developer, and I see those as different. But how many of you have heard the phrase functional style JavaScript? Right, you should be doing functional JavaScript because JavaScript is functional. You shouldn't be doing non-functional JavaScript because that's dumb, and why would you do that? And I'm a little history. So I started as a Java developer. I actually started as a mumps developer. Who's heard of mumps before? Right, it's interesting where I go. Like I was in Omaha and half the room raised because they have a large healthcare population. So I was a mumps developer, I was a Java developer, I was a .NET developer, I've become a JavaScript developer. I've done all this stuff, and I've always been a procedural OO kind of developer. And so I've brought those skills into my JavaScript. And so I actually have a course on Pluralsight. It's like the Gang of 4 design patterns in JavaScript. And kind of that's where my head's at. So, side note, I'm a Pluralsight author. I do mostly JavaScript stuff, some Node stuff, some JavaScript stuff. If you do not have, who does not have a Pluralsight subscription? Several people. Okay, I have trial cards, like free 30-day all-access cards. If you want one after the talk, come and let me know and I'll get you one. Okay, but I have a lot of friends who also do JavaScript who are like hardcore, like religious zealot kind of functional developers. And they talk about JavaScript this way. They say, no, JavaScript is a functional language because functions are first-class objects. And I say, well, it's more of an OO, not necessarily functional language, because functions are first-class objects. Now I know, for the functional people in the room, I know that object-oriented and functional are not opposed. You can have, but bear with me. Okay, so I got into enough arguments over the years with people about functional programming, I didn't really even know what it was. So I'm going to, for those of you who are not aware of what functional programming is holistically, because this talk is going to be about, first of all, JavaScript is not a functional language, period, full stop. However, there are aspects of functional programming that will make your life a lot easier when you're writing JavaScript. And so that's kind of where this talk goes. Just so you know, if you're already angry, you can leave. It's fine. So what I did is I went and looked up what is functional programming so I could understand really what it is and then apply it to JavaScript. So where do you go when you want to know what something is? In America today, right? You go to Wikipedia because this is the source of truth of all knowledge. I explained to my children, I've got a 13-year-old, a 16-year-old, and a 20-year-old, that when I was in school, this didn't exist. And I still graduated. So like no excuses in today's world. All the answers are right there on one page. So here is the actual Wikipedia definition of functional programming. We're going to walk through this and then we're going to apply this to JavaScript. Okay, so in computer science, functional programming is a programming paradigm. Stop. Let's skip past that. Okay, so this is important. We're going to come back to this quite a bit. It's a style of building the structure and the elements, the pieces of computer programs that treats computation as the evaluation of mathematical functions. Right. So, backstory, I was a math major in college for 1 year. We had the quarter system. I took Cal 1, Cal 2, and Cal 3 in my freshman year. Guess what I was my sophomore year? Computer science major. Because I looked at the rest of my math and said, there is no way I'm continuing on with this. This is ridiculous. Come to find out, Cal 3 is like the hard. Do I have math majors in the room? Like Cal 3 is the hardest, and then it kind of gets different and easier. So I don't know. It worked out. But I hate math. Like math is horrible. And so now we're talking about applying math to programming, which immediately makes me sad. Okay, so my daughter was doing algebra homework a couple of years ago. She asked me to help, and I walked in and I saw this. I was like, oh, you're doing functions. I know functions. It's what I do. And she's like, yeah, Dad, I know. You're a programmer. This is math. It's not the same thing. But it is, right? Okay, so this is a mathematical function. And so we say, mathematical functions, this is what we're talking about. F of x equals x plus 2. What happens if I put 3 in for x? What do I get? 5. Always, right? You know that that's how that works because it's a rule that says if I put 3 in there, I'm going to get 5 every time. When they say it treats computation as a series of mathematical functions, this is the kind of thing we're talking about, right? We're going to have these little functions that just represent changes in data. I'm going to pass data in, it's going to do the same thing every time and go from there. It's more complicated, and then we get to this gem. And avoids changing state and mutable data. So just so we're clear, you can change object in JavaScript. Like the very core underlying things. Track.js, I don't know if you're familiar with Track.js. If you aren't, go out there. They've built a whole company on like making changes to function and making changes to objects so they can capture things as they go. Nothing is immutable in JavaScript. Everything is always changeable. You can use, object.freeze. Guess what? You can still change that. So we'll come back to this. Just understand that. Okay. That is why, ultimately, this talk is not called functional JavaScript. This talk is called functional style JavaScript because we're going to apply styles, but it's not functional for a couple of reasons. Here's the big one. So Ordersky says this. The programmers in that segment being functional programming, like functional programming because it makes code clearer, better structured, and it prevents many classes of errors. So this is what we're striving for. How many of you would like your JavaScript code to be clearer, better structured? Yes, please. Let's do that. And it prevents many classes of errors. That one's a little harder for us because in real functional languages, Elm, Scala, those types of things, there's this thing called a compiler. And this compiler will check all of your code to make sure you're not changing things and make sure you don't have side effects and all this stuff. And so the tooling actually does a lot of the work. But you might hear people talk about this. This is my favorite. Pure functions are awesome. I had lunch with a guy. He was a hardcore functional JavaScript guy. He actually said the phrase to me out loud. Randomly at lunch. When I'm writing a function and I can trim it down to be like just a pure function, that's like the best feeling ever. Really? That's kind of sad, actually. But why? And so I posed the question, why? And he's like, because it's pure. How can a pure function be bad? It's in the name. It's awesome. Pure is good. Not pure is bad. It's just baked in. Side effects are evil. No side effects in your code, please. Whoever needs to write to a database or do I/O work or print something to a side effects are literally the only thing that matter in your code. Because if your code has no side effects, it doesn't do anything. Okay, so we'll come back to that. But a lot of times when I'm talking to I'm gonna clarify something. When I talk to a functional developer who does Scala or something like that, they know the answers to all these questions. Usually when I'm talking to a JavaScript functional person, they're like, it's all zealotry and I have no idea why we do this because it's fun. That's why. Tail recursion, look it up later. We'll come with that. Okay. So here's where we're going to get to it. The programmers in that segment prevents many classes of errors. I talked about this. The tooling does the work. In JavaScript, you don't get that benefit. A lot of those errors still can happen, and you won't know about it. And so it kind of hides them. So we'll talk about that a little bit. Okay, so I was pretty against it. And then I met this guy called Nate Taylor, who is so famous, he has his own Pluralsight icon. We don't know why it's the icon for a developer, because even Pluralsight thinks we all wear hoodies and are bald. So he sat me down. He actually has a course, Functional Style JavaScript. And he sat me down. He's like, no, you're missing the point. You're thinking about this completely wrong. Because it's not about perfection, right? It's not about eliminating all your side effects. It's not about keeping everything pure, because you can't. It's about, nothing has to be immutable, because nothing's immutable. But it's about the small pieces and making things understandable and making things easier to read and reason about. So functional style programming here's the key. Who wants this? Using less brain power and making things simpler. We want to make our code simple and easy to reason about and easy to understand. It's about small composable things. I want you guys to think about it this way. A style building the elements. Okay. This is Europe at night. I had America at night, but there's like a big gap where it's still black. So I want Europe at night, there's no gaps. Everything's lit up. Even the middle of the ocean, which is weird, in between Norway and the UK, there's lights there. It's not even dark in the ocean in Europe. There's all of this stuff. And so when I think about an application, and honestly, when you think about your application, oftentimes you think about this, right? So there around, in Italy, we've got the database, and up there in the Netherlands, that's our UI, and all these pieces fit together, and you can see how the roads go, and all this stuff fits together. This is how we think about applications a lot of times. I'm going to challenge you to not only think about that, but spend a lot of time thinking about this. Because honestly, it's a lot of those that make up this. And oftentimes we blaze through these things thinking about the big picture, we forget the little. And so what we're talking about with functional style is think about the small composable things that you can reuse and you can adapt and go. Okay. Think about the small pieces first. Okay, so, but honestly, you got to focus on both, right? You got to keep an eye on the big picture, but go with the little picture as well. Okay, so let's look at some code, because we're 12 minutes into the talk. I haven't had any code yet, so let's spend the whole rest of the time looking at some code. Okay, who in the last 7 days has looped over an array and done something with said array? Right. Who in the last 7 hours has honestly looped? I mean, right? This really honestly, and this makes me sad to say out loud, but honestly, a good chunk of a developer's career is pulling data out of a data source of some sort, looping over said data in an array, manipulating it, and then displaying that data to some sort of output. That's your job, summed up in a really sad little, right? All this cool stuff we do, ultimately that's it. So I'm going to use arrays to talk about it. Now, you may be familiar with some of the array stuff we're talking about. I'm going to use the arrays as a context to discuss the overarching functional principles. But let's look at this. Okay, this is a for loop. Real quick, shout it out. What is this for loop doing? It's taking you way too long. Right, it's looping over 1, 2, 3, 4, 5 and doing what to it? Adding 1. Okay. So what's console.log going to print out? This is not a trick question, but it kind of proves my point, right? 2, 3, 4, 5, 6. This is about as simple a thing as I could possibly come up with, and either you're really shy or you had to think about it for a minute. It's like, wait a second, what's going on there? There's actually quite a bit going on in this one thing. Right? You've got some iteration code. This is the code that decides how you're going to iterate over it. Because I don't know if you're aware, maybe you're not. You don't have to do I++. How many of you ever don't do I++, right? I mean, you could do I plus 2 or, I minus 1. Sometimes we do minus 1, right? But ultimately, this line tends to be exactly the same, a lot. And then the important code, the worker code, is down here inside the brackets. Now this is incredibly simplistic. Usually what's inside this brackets tends to be a little bit of code, but we've got worker code, we've got iteration code, and then we've got the output. So we're going to simplify this a little bit. Remember, because what we're talking about is small composable things. We want to write composable things that we can reuse and we can join together and make things a little bit easier. So we're going to break this up a little bit. Built in to array in JavaScript is a whole suite of functional style tools, or functions, if you will. Let's take our iteration code and do map. List.map. Who's used list.map? If you're a React developer, you've done, right? Everybody's done this. And that's why I like using this example, because you're all familiar with this, and so I can make a couple of points really easily without having to explain all that. So list.map is basically that. Because remember how I said this is what you're going to write over and over and over again? So we just create this function called map that does that for you. Now I don't have to worry about it, right? And then it takes a function. Now here's where, all right, what were we doing? Do you remember? We're incrementing 1. That's all we were doing. Right? So we've got this worker code, and basically what we're going to do is we're going to create a function that's going to do this worker code for us. It's going to be a little bit easier to reason about, easier to understand. But it has to be a pure function. So let me ask, who's heard, so you've heard the term pure function. I know you've heard it because I've said it in this room a couple of times. What is a pure function? Who knows? Who can just belt it out? What defines a pure function? No side effects. Excellent. What else? Remember when I said, here, so in computer programming, a function, this is Wikipedia again, a function may be considered a pure function if both of the two, so we had 2 things listed and both of them have to be true. The function always evaluates to the same result value given the same argument. So, right? Always, if I pass in 3, I always get back 5. That's a pure function, right? But a pure function, oh, right. A plus B is pure. Math.random, does that always pass back the same thing? No, not a pure function. And evaluation of the result does not cause any semantically observable side effects or output, such as mutation of mutable objects or output to I/O devices. That one's a little bit more wordy, but ultimately it says no side effects. Can't change anything outside of itself, right? Sum equals 0, sum, that's not pure, right? That function is manipulating something outside of it. Now let me ask, why? So back to my question before, somebody was very excited when they wrote a pure function. Why do we care? Why do we care about having pure functions? Easy to test. That's the one I get every time, always. Well, it's easy to test. How many of you, be honest, write tests for every function you write? So, yeah, so for the record, for the 3 people in the room, and actually 2, and one of them was like, kind of, right? So easier to test, well, interesting, is not necessarily as critical to the room at large. Why else? Portable and reusable. Remember, it's small composable things. If I write a function that adds 1 to whatever is passed into it, I can use that anywhere. And I know it's going to work, and it doesn't change other things. I can reuse it. So here's the thing. Remember, functional style is about using less brain power and making things simpler. So pure functions, less complexity. I know what's happening. I can look at a function name. I can see what it's doing if it's named appropriately, and I don't have to worry about it doing anything else. It's easier for me to think about. It's easier to test. I did throw that one in there, even though the vast majority of the room doesn't care, but you should be writing more tests than you probably are right now, so this is a good way to get started. And it's easier to understand, because ultimately this is the point. We want to simplify our code, make things easier, make things more, I want to just look at it and know what's going on. So let's look at that. So here I've got list.map, function, item, return, item plus 1. So that's a little simpler. Not a lot simpler, but a little simpler. I could do that, right? Because arrow functions are the bomb now, right? Everything should be an arrow function, even though they don't really need to be. But really, this is still complicated. And actually, I used to work with Corey, and Corey did code reviews, and Corey would say, no, it should be that. Because there's a whole bunch of extra keystrokes involved here. So just do this, item plus 1. But really, that's still not as clear as it could be, right? What if I named this function? I am not a huge fan of anonymous functions. Now, you can go overboard, and I'm saying don't go overboard, but name your functions, because I have to look at this and I have to think to myself, what is this doing? Even though it's one line and it's item plus 1. Like, I get it, that's easy. But I have to look at this and I have to think about what it is. What if I just said what it was doing in place of the thing, and I just said list.map add 1? If you look at that code, list.map add 1, you don't even need to look at what the function actually is. You can read that and say, hey, I know what that's going to do. That's kind of easy. It's simple. We went from this, which is a lot, to that. Very simple, very easy. What's it going to print out? 2, 3, 4, 5, 6? Who says yes? What's it actually going to print out? Those of you who know the right answer. 1, 2, 3, 4, 5. Correct. Right, 1, 2, 3, 4, 5. Why? Why does it print out 1, 2, 3, 4, 5? It's a pure function. It doesn't mutate state. Remember, another aspect of functional programming is we don't change things. Now, there's reasons why we don't change things, and we'll talk about that, but it's 1, 2, 3, 4, 5. Because, according to Wikipedia, functional programming avoids changing state and mutable data. We don't want to change things behind the scenes. And there's reasons for that. There's like practical reasons for that. There's zealotry reasons for that. But I'm going to talk about some practical reasons why you don't want to just change things arbitrarily. What if I want 2, 3, 4, 5, 6? What do I have to do? Hey, new list. Just create a new variable. New list equals list.map. Well, now I've got 2 things. That potentially is painful. What if I want list to change? I just say list equals list.map. I can do that because I'm in JavaScript and things aren't immutable. So I can actually just do this, and I'll get 2, 3, 4, 5, 6. But I don't know when I write the map function which of those 2 outcomes you're looking for. So I don't change anything, and I leave it up to you to make that change. That's one of the practical benefits of immutability. So why are we immutable? Why? I kind of gave you a little bit. Why would we be immutable? Why do we not want to change things under the hood? Anybody? Right. So here's one reason, React. So if an object changes, if you make changes to an object, it doesn't actually change the object, right? So if you want to see if something has changed, you can do, so state in React. Who does React? State is considered to be what? Immutable. Very important distinction. State is considered to be immutable. It is not actually immutable. That's important to understand because I have seen lots of code that just changes state and then they don't know why things aren't working. Because that's not how it works, right? And the reason why it doesn't work is because what React does is it looks at old state, compares it to new state this way. It says, hey, has this state changed? If it has, re-render everything. If it hasn't, don't. So if you're just changing things under the hood, it's not going to work. It enforces options. This is the practical thing we were just talking about. I don't know what you want. I'm going to make you decide what you want, and I'm just going to hand you back something new, and you decide whether to apply it to the old thing or the new thing. And it's easier to reason, your thing. It's not changing all this other stuff, right? I know nothing has changed when I call this thing, and so there's comfort in that, and I can reason about it a lot more easily. We don't always just loop over, right? Things are sometimes more complicated. Remember that sum thing I was talking about? I want to sum that list. There you go. Let I equal 0. I++. Is what's inside that for loop pure? No. And I have to now pay attention to the fact that there's this sum thing out there. And I have to understand what sum is and what it means and how it's changed and all this stuff that's complicated. But the output is 15. Array, remember I said array has a whole suite of functional style tools associated with it, or functions. So I can just actually do reduce. You may have noticed 2 buzzwords that were huge a few years ago, map and reduce, right? So you can map reduce a data set with an array, because mapping is I'm going to do something to every item, and reduce means I'm going to aggregate items together and present you a new output. So I've got a reduce that I'm passing in 0, so list.reduce 0, and it's going to sum the list. How do you know it's summing the list? The function is named SumList, right? Where do we start? We start at 0. It's just that easy. Sum equals list.reduce, SumList 0, right? You can look at this right here and say, I know exactly what this is doing. I know it's not changing anything else outside of it. I can test my sum function easily. All of that stuff can be boiled down, and I know, hey, I'm getting 15 when I print this out. That's why we do it. What does this do? It what? There you go. It filters, right, finds the even numbers, filters out the odd numbers, and you didn't even have to see anything around it, right? List.filter is even. Give me all the stuff back from my function that's even, right? This is why we apply these functional principles, because it makes it super, super easy. Another reason why we don't change things, and we return, I can chain all this stuff. That's kind of fun. So who did jQuery? It's not the same at all, but jQuery is always my fun thing to mention when we're like chaining things, because we used to like big, massive chains. We can chain all this stuff. What if I want to add 1 and then sum it? So I've got 1, 2, 3, 4, 5. I'm going to add 1 to it, 2, 3, 4, 5, 6, and then I'm going to sum those, and I'm going to come up with some number that I'm not going to try and describe right now, because I'm not going to do the math in my head while everybody's looking at me. But it will come back with a number that would make sense, right? And so this is another feature that you get by not just changing what list is. I'm returning the new thing, therefore I can chain and I can build all this stuff out. All right, this one becomes a little bit more complicated. I have a list: John, Jack, Mary, Susan, Sarah. I want to find Mary. So there's a list.find, and it's going to return back the item that I have found. So I pass in a function, item equals Mary. That's great. But remember, I don't like anonymous functions, right? So we're going to pull that out. And I'm going to have getPerson. But getPerson now has Mary hard-coded, which is not what we want to do, right? So I want to be able to pass into getPerson the thing that I want to find. I want to do that. But find takes a function, right? So we now have this concept of higher order functions. Now you use higher order functions all the time. We've used them all throughout the demo so far. But a higher order function is this. Okay, in mathematics or computer science, a higher order function is a function that does at least one. Remember, in pure functions, you had to do both. In higher order functions, it only has to be one. It either takes one or more functions as arguments. Map, reduce, all of those things, they were all taking functions as arguments. They are higher order functions. The other alternative is it can return a function as a result. I can return a function. When I return a function, now I am also a higher order function. So what if, in this case, I create this thing called getPerson that's a function that returns the thing I'm searching for, right? So getPerson Mary, and what getPerson's going to do is return the function that filter is going to use, or find is going to use, to find Mary. This is a higher order function. This getPerson is a higher order function because it's returning a function. And then I can, trim it all down and make it all nice. And I'm list.find getPerson Mary. Now what's console.log going to print out? Anybody know? Is that right? Are you guys just shy? What's it going to print out? It's going to print out Mary, which is not useful to me at all, right? Because now it's a string if we were doing objects. But so really I want find index, which will return the index, right? That gives me the number 2 instead. All right. Let's talk about currying. So we talked about higher order functions, pure functions, all of those things. Currying is weird. Okay, so let's look at this. In mathematics and computer science, currying, that's not a joke. It's weird. Currying is the technique of translating the evaluation of a function that takes multiple arguments into evaluating a sequence of functions, each with a single argument. That makes total sense, right? Here's currying. Sum, add, A, B. Boom. That's currying. We go from that to that. Welcome to functional programming, ladies and gentlemen. No, okay, but we've actually already done a little bit of this in the previous example. So I'm going to contrive an example that's something you all might be familiar with that talks about currying. Okay, so we have a list of buttons. Button 1, 2, and 3, and we're going to print these buttons out on the screen, and when you click a button, I want to display the message associated with that button. Okay. So onClick passes me an event. And when I get the event, I have to loop over the buttons to see what the message is for the specific button that was clicked. That stinks. And depending on how many buttons, may take a little while. What I really want is this. I want an index of the button that is being clicked, and then the event that was to know whether it was clicked or what else was happened to it. And then I don't have to loop over it. I can just go straight to the index. So now I have a function on click that takes index and event both. I have that. But what I really want is to separate those two things out, because guess what? I'm not going to be able to change the browser to pass the index in to onClick. Like, that's baked. I don't get to play with that. But what I can do is split this up into a series of functions, and I can say, hey, remember when we did this? I created a function called getPerson that returned the function. What if I create a function that gets the message and then returns the event handler from there? Okay, so here's what we got. Check this out. Get onClick index. I'm going to pass the index in. And then I'm going to return a function that takes event that references index. How do I know what I keep index because of what? What's the term? Closure. Excellent. Good job. Right. So because the closure in JavaScript, if you're not familiar with the term, means that when this function event message equals buttons, when that is created, I keep the scope of everything that exists when that function is created. That's called the closure that's around that function. So I get to keep index, even though it's outside. Awesome. And then I can just say onClick this.getOnClick index, item.name. Done. So that's a practical example, or a little bit of a contrived example of currying, right? Because here's the core. Here's ultimately what it comes down to. Don't think of functions the same way you think of functions in like a .NET world. In JavaScript, I have a function, and that thing can be passed around. I can move it over here, and I can reuse it in multiple places. And so if I need a function that's a little different than what I have, I can create something else that's going to generate the new function that I need. And then I can pass that function in. So that's ultimately where currying comes in. Okay. Well, I think we're at time. So who's heard of Monads? Okay. Who can and would be willing to come up here, take the microphone, and explain Monads to the group? Right, okay, so there's actually a thing called Crockford's Law that basically says, and so Monads are complicated. And when you take the time to really dig in and understand and apply Monads and really figure them out, by the time you've gone through that process, you are no longer able to explain Monads to other people. That's what Crockford says. I am going to attempt to prove that to be true. Because I'm going to give you at least a taste or an explanation of what monads are. There's actually more to this law where it's like, well, you can explain it, but it's going to come out sounding stupid. It's going to come out sounding like, well, why in the world would you ever need that? Well, here we go. So, a monad at its core, before I even go into code, I'm just going to explain this. A monad at its core, think about this. We can't have side effects. We can't change things. Things are immutable. And so at some point, I need to make changes to things. So what if I can wrap everything up in a series of functions and protect all of my side effects and all of my mutability and all of that stuff? I'm going to protect it inside this case and only address it with functions. That's essentially, and we'll get into that's essentially what a monad is. It's basically, here, let's, in functional programming, Wikipedia, a monad is a design pattern. First of all, it's a pattern, not a thing. But a monad is a design pattern that defines how functions, actions, inputs, and outputs can be used together to build generic types. Who does objects? Very simply, think about it similarly to like an object. It's just an object. It's a construct that you deal with. Okay, I'm gonna show you. Define a data type and how the values of that data type are combined. Okay, I'm going to show you a very basic one, and we're going to create a data type, and then we're going to create a function that massages that data type and call it a monad, because it is a monad. It's the simplest of all monads. It is, ignore that because I don't care about that. The identity monad. I'm going to step down here because I'm going to point at things, but I'm not going to go past the tape. Okay, so the identity monad is the simplest of all monads, and so we're going to walk through an identity monad so that you can get an idea of what a monad is. Okay, so here you go. Function identity monad. It takes a value and it assigns that value to this. So I call identity, and now I have a thing. Var x equals new identity 5, x dot value 5. Now, I'm already kind of breaking it because I shouldn't access value directly. I know the functional guys are like giving me stink eye. I should have a function, but for the sake of this discussion, I'm just going to keep it simple. Now, I want to change value. I can't change value directly because then I'm changing things. It's not immutable. I'm going to create a function called I hit the wrong button. I'm going to create a function, there we go, that will change things for me. So I'm going to call it .bind. So don't, remember monads are like a functional thing holistically, not a JavaScript thing, and so don't confuse this bind with like the bind function that sits on function. So I'm going to use this identity prototype bind, and that's the function that's going to be called to change the value. Right? So I have function transform. I'm going to return whatever, so transform is the function that's being used to change the value. I'm going to return that function executed with whatever the current value is. Okay, so let's look at this in practice. So I have value, and then I have a function, the transform, that's going to, whatever function's passed in, I'm going to execute that function with value. So here, if I say x.bind, and I pass in a function that creates a new monad, why are we creating a new one? So we don't mutate. And we're going to add value plus 2. So I have I'm passing in a function that adds 2. Bind executes that function. So if it started as 5, now I have 7. So here's the thing, and don't take this too literally. In a purely functional language, you have a lot of restrictions and implications. It's not quite as complicated in JavaScript, so you don't really need to get deep into monads because you can change things. And actually, you can really change things. But before I get back to this, think about this. You have an object that you create when you make an asynchronous call. And then you want to get the data out of that asynchronous call. Think about a promise, right? So I've got a promise. You can't get directly to the values in a promise, right? You have to pass functions in. And so it has two functions, right? It's got a resolve, and you can do catch, right? So promise.then, I pass a function in, and then when a resolve happens, it pulls it back. Promise.catch, I pass a function in. Promise is a monad. It's not the identity, but promise is an implementation of a monad, so you use them all the time. And they serve a purpose because they don't want you in there mucking around with all the stuff. Now, if you want to, you can create all kinds of havoc by actually like going in and changing things. Don't do that because we want things to be clear, right? And so what sometimes that promise structure does is it makes things a little bit easier to deal with. But remember holistically, this comes back to the skeptical side. Remember holistically, for real hardcore functional programming, the tooling does the work, right? Because I actually can do this. So there at 7, I can actually just like change value. And there is nothing I can do to prevent that from happening. So it doesn't get us all the way, but it does give us some tools to simplify our code a little bit and make things a little bit easier. Just don't pretend that state is actually immutable, because it's not. All right. So in JavaScript, right, it's the mindset. And this is the mindset I want you guys to walk away from today out of this, is think about your functions as a lot bigger things than you probably treat them as right now. They're like things that you can do stuff with. And you can pass them around. And you can compose them, right? I can take this function and this function, I can compose them together, I can pass one into the other one. Start thinking about your functions as tools instead of just this thing I can pass data into. Simplify your pieces. It's okay. Like, to really spend some time looking at the code you wrote and think, how can I simplify this and make this easier? Because there is no code that is worse than the code you wrote 6 months ago, right? How many of you have ever stepped away from code for several months and come back and be like, what was this idiot thinking? And you do a git blame, and like, oh, I'm the idiot. Okay. The more simple you make it, the more you break these pieces apart and simplify, the less you think of yourself 6 months from now as an idiot. Keep your interactions simple. Right. All right, so, questions. Well, actually, I tell you what. If you have questions, come up, chat with me. If you want a Pluralsight, they're circular, that's why I'm doing this. A Pluralsight code, if you don't have an account, come up. I've got some of those. Otherwise, welcome to NDC, Minnesota. Enjoy the rest of your day. Hey, there you go.